Alright guys, so last video on average rate of change, and I'm not teaching you anything new today. We're just going to use what we've learned and we're going to compare, okay? What does comparing mean? Okay, we are going to look at different average rate of change. We're going to compare them, like we're going to say, alright, who's least, put it in order from least to greatest. So who's the smallest, who's the medium, who's the biggest, okay? Or we're going to say put it in from greatest to least. Okay, that's what I mean by we're gonna be comparing average rates of change. So I'm gonna give you 3 different representations. We're gonna find the average rate of change, and then we're gonna put them in order that the question asks to do it in. Okay, so there's really no notes. It's really just gonna be hopping into an example. Okay, which that is not it. We went backwards. There we go. All right, so given the functions, g of x is right there, f of x is the table, and h of x is the graph. I want to know what is the order. I really hate that it does that. I want to know what is the order of these functions. Let's rewrite it. From greatest to least. So from greatest to least. So that means I need it in order from big to small. Okay? Over the interval 0 to 3. So I'm going to use the interval 0 to 3 each time. Okay? And we're gonna have to find our average rate of change 3 times. But really and truly, let's be honest, the only one that requires a lot of work is the equation one. So let's go ahead and do that one first. So it states my x's are 0 and 3. So we know 0 and 3 go on the denominator. So 0 minus 3. Now I have to plug 0 into this equation. So I'm gonna say 0 squared minus 2 times 0. 0 squared is 0. 2 times 0 is 0, so guess what my answer is? 0. Now I'm going to plug 3 in. 3 squared minus 2 times 3. 3 squared is 9. 2 times 3 is 6. 9 minus 6 is 3. So 0 minus 3 is negative 3. 0 minus 3 is negative 3. What's negative 3 divided by 3? It is 1. So g of x's average rate of change is 1, okay? All right, let's switch colors since we're switching functions. Okay, so now let's go to the table, okay? Again, 0 and 3 are my denominator. Let's find their pairs. 0's pair is 1. 3's pair is 7. 1 minus 7 is negative 6. 0 minus 3 is negative 3. Negative 6 divided by negative 3 is 2. So this function's average rate of change is 2. So far it's the biggest. Okay? All right. Now let's do the graph. So 0 and 3 are my denominator. Now we need to find their pairs. So when x is 0, which is right here, that is 0, my y value is 2. Minus, when x is 3, my y value is, we're going to say 9. So 2 minus 9 is negative 7. And then 0 minus 3 is negative 3. Well, that can only reduce down to 7 over 3. I would get the decimal for that since we're comparing. Okay, I know I said average rate of change, I like them in fraction form, but since we're comparing, let's put it in decimal form, and it's going to be 2.333. Okay, so it's going to be that repeating decimal. So we're just going to put 2.3 just so we can compare it. Okay, so I want to put it from biggest to smallest. Okay, so who is the biggest? Well, 2.3 is the biggest, so that means h of x is the biggest. Okay, and then after h of x, who is the next biggest? It's going to be the 2. So now it's going to be f of x is next. And then after f of x, it's going to be our g of x. All right? And that's really what you got to do. And you just put commas between them. Okay? All right. So let's do one. Let's do a delta math one because you're going to have a delta math on one like this. So let's end, keep. So I've already snipped it. Here we go. So I want to compare these 3 graphs, okay? Now I'm going to go back to the screen. Oh, man. Let's see. I think I lost the screen. I didn't even think about that. Yeah, I lost the screen. I forgot to snip the interval. Okay, we're just going to make up an interval, okay? We're going to say, let's see. We're going to say 4 and 8. Yep. Because that's the only thing. Yeah, so we're going to say on the interval 4 to 8. Okay, so I want to put this in order from interval from 4 to 8. Okay? All right, so that means that's my denominator. Okay, let's start with the equation since it is, I would say, the most difficult. Okay, so I'm going to plug 4 in first. Okay, let me get my calculator. All right, and I would type this one in since it's one of those, it's a quadratic, okay? Type it all in. So I'm going to replace all my x's with 4. So it's 4 squared minus 5 times 4 plus 22. Once you write it out, just type that into your calculator just how you see it with parentheses and all, okay? So I get this to be 18, okay? Now we're going to do 8. We're going to replace all our x's with 8. Okay, and I get it to be 46. Okay, so 18 minus 46 is going to be negative 28, and then 4 minus 8 is going to be negative 4, and 28 divided by 4 is 7. Okay, so that average rate of change is 7. All right, now let's go to the table. Okay, so my denominator is 4 minus 8. Now find their pairs. 4's pair is 28. And then 8's pair is 8. So 28 minus 8 is 20. And then 4 minus 8 is going to be negative 4. 20 divided by negative 4 is negative 5. Okay? All right. So the next one is the graph. Okay? And it's going to be 4 minus 8. So 4's pair, if you look, 4's right here, its pair is 2. 8's pair is negative 2. So 2 minus negative 2 is going to be 4. 4 minus 8 is negative 4. That gives me negative 1. Now, I've seen on multiple sites about the negative numbers, but on Desmos, it wants you to treat the negative numbers like the negative numbers, okay? So order least to greatest. So yeah, let's do least to greatest. So we're going to do small to big. Okay, that's what we're going to do. We're going to do small to big. So who's the smallest rate of change? Negative 5. Remember, negative numbers are backwards. So my negative 5 is my smallest. So g of x is my smallest. Next is going to be my negative 1, which was my f of x. And then finally, it's going to be my h of x. Okay? And that's all you have to do for this Delta Math when comparing. And it's multiple choice. Okay, I just snipped that out. But you're just picking the one that is small to big. Okay, and it didn't take that long. All right. So now let's go back to the PowerPoint, and we have one more that we want to do with comparison. So this one, I give you one table, and I want you to figure out on which average rate of change is the function the greatest. So out of these 4 multiple choice questions, which one makes the table have the biggest rate of change? Okay, so guess what? It's going to be a trial and error. You just have to do it. You just have to do all of them. Okay, so let's do all of them. So let's just start. I'm just going to start with the first one. Okay, so we're going to do, I'm going to do my color coding. So we're going to do this one in red. Okay. All right, so those are my x's, so that's my denominator, right? So it's going to be 5 minus 14. Now find their pairs. 5's pair is 81. 14's pair is 116. Okay, so we're going to say 81 minus 116. That gives me negative 35 over 5 minus 14, which is negative 9. 35 divided by 9. Yeah, I didn't think so. Can't be reduced down. But just for comparison purposes, we're going to put in parentheses that the decimal version is 3.89. It's really 3.88 repeating, but we're just going to round just for comparison purposes. All right, let's change colors to that color I like with this background. All right, so now we're just going to do the next one, 18 and 30. So 18 minus 30, okay? So 18's pair is 180, and then 30's pair is 242. They would give us big numbers, wouldn't they? Oh, I guess I chose these, didn't I? Negative 62 over 18 minus 30, which is negative 12. 62 divided by 12. It can reduce down to 31 over 6, but that really doesn't help us in comparison. So we're going to put in parentheses that this is 5.1 is 5.166 repeating, but we're going to put 167, okay? All right. Onward to the next one. Let's do this guy, 14 to 18. So the denominator is 14 minus 18. Let's find those pairs. 14's pair is 116. 18's pair is 180. And it's also really cool doing this because you're seeing that on a nonlinear table that the rate of change is different between each interval that I'm choosing. You see that? So you know this is a nonlinear function because my rates of change aren't the same. Like you should have learned in Math 1 that a linear function, no matter where you do the rate of change, it's going to be the same thing. So this is obviously not a linear function because I'm getting different rates of change every time I'm doing a new interval, okay? Just a little mini lesson there. 64 divided by 4. We got a whole number finally, 16, okay? All right, I did that one right? Yep, 64. Okay, so now last one in this example, and let's do purple. So I'm going to do this guy right here, 30 to 39, so we're going to put on the denominator 30 minus 39. Find 30's pair, which is 242. 39's pair is 311. Use our calculator. Had a student who used to say that all the time. 30 minus 39. Let's see, 69 divided by 9. Wait, I don't think it can. Yeah, it can reduce. So it reduces down to 23 over 3, which in decimal form is 7.6, but we're going to say 67. All right, so I want to know who has the greatest interval. Okay, so looking at all of these, who has the biggest rate of change? Well, it's going to be the 16 guy over here, so it's going to be the one in green. Oh, I thought I hit highlighter. So this guy right here is our answer. Okay, so it's just a little work, but it wasn't that bad. Okay, all right, so let's do, so that's the end of this. So let's do a Delta Math one. So let's do the Delta Math. I have it snipped. Here we go. All right, here's another table. Okay, and this one wants to know who is the smallest. Okay, so we're just going to do what we just did. Let's do this guy first, 1 to 5. So we're going to say 1 minus 5. 1's pair is 5. 5's pair is 21. So 5 minus 21 is going to be negative 16. 1 minus 5 is going to be negative 4. Negative 16 divided by negative 4 is a positive 4. All right. So next one. Next. Here we go. 15 and 26. That is our denominator. 15 minus 26. Find the pairs. 15's pair is 25. 26 pair is 30. So we're going to say 25 minus 30. Oh, and I get negative 5. Then we're going to say 15 minus 26, and I get negative 11. Well, we know that reduces down to 5 over 11, but let's put it in decimal terms since we're comparing. And it's going to be 0.45 repeating. Okay. All right, next is going to be 5 to 15. So we're going to say 5 minus 15. And then 5's pair is 21. 15's pair is 25. 5. So again, this function is also nonlinear because we're getting different rates of change, okay? So that's going to be negative 4. 5 minus 15 is going to be negative 10, I do believe. I just want to check myself just because you don't want to get it wrong up here like I have before. So 4 over 10 can be reduced to 2/5. And then 2/5 in decimal form for comparison purposes is 0.40. Okay? All right. Last one, let's make it an orange. So 26 to 52. So 26 minus 52. 26 pair is 30. 52 pair is 38. So 30 minus 38 is going to be negative 8. 26 minus 52 is negative 26. 8 divided by 26 reduces down to 4 over 13. And in decimal form, it will be, it's not, no, it is, no, it's not repeating actually. So we're going to say 0.31. Okay, we're going to round it. All right, so it's asking for the smallest guy here. Okay, so who is the smallest? Well, it's going to be that 0.31. So it's going to be D. Okay? All right, so let's go back to the Delta Math and see if I did all the ones. Let's look that you're going to see. All right, yeah, we did one like that. I think it's this I want to look at. All right, yes. Here's a graph one. Let's do a graph one, okay? Of this. I haven't done one like this. All right, so it wants to do the smallest, okay? Again, which is what we just did, the smallest. All right, so this one's not any harder. It's just I want to make sure I'm showing you all the ones you're going to come across today in. So we're going to start just with A. We're going to do 0 to 2. So the denominator is going to be 0 minus 2, okay? So at 0, my x is what? My y is what? 72. They even give you the coordinates. That is awesome. So at 2, when x is 2, which is right, because, I mean, look at the graph down, the scale down here. So that's really cool. Makes life a lot easier. Here is when x is 2. When x is 2, what's y? 155. Okay. So I'm going to say 72 minus 155. I get negative 83. 0 minus 2 is negative 2. Doubt. So can't be reduced down. So, but it is 83 over 2. And in decimal form, that's going to be 41.5. Okay. All right. Next one is going to be, we're just going to go through it. 6 and 13. So 6 minus 13. When x is 6, y is 215. When x is 13, y is 283. All right, so 215 minus 283 is going to be negative 68. And then 6 minus 13 is going to be negative 7. 68 divided by 7. It is just 68 divided by 7, which in decimal form is going to be 9.71. Okay. Oh, run out of space. Hate it when that happens. All right. Let's do a blue. Let's get a blue up in here. All right. 2 and 6. We're going to say 2 minus 6. Find the pairs. 2's pair is 155. 6 pair is 215. And again, what do we notice? That this is a nonlinear function because why? Answer it. It's because the average rate of change are different. Okay? 155 minus 215. I get negative 60. 2 minus 6, I get negative 4. 60 divided by 4 is, it's even 15. No need to do a decimal for that one. All right, let's do I'm digging a green. Let's dig a green. All right, 13 and 27. So we're going to say 13 minus 27. 13's pair is 283. 27's pair is 346. So 283 minus 346 is negative 63. 13 minus 27 is negative 14. We do the division, and I get 4.5 because I don't think it can't be, oh, it can be reduced. 9 over 2, which is 4.5. So this one wanted the smallest one. So who's the smallest? The last one we did, the 4.5. Okay, now the answer's not always D, guys. I know the past two were, but don't be assuming that, okay? All right, so that's it for comparing today. That's it for average rate of change. So let me know if you have any questions, all right?